This is Chemistry 12, Acids and Bases Unit, Lesson 4.14. Topic is Ka calculations. For starters, we'll talk quickly about what is Ka. Weak acids have a Ka. So anything below the top six on your table, so underneath the top six are our weak acids. If they're near the top of the table, they will have a larger Ka, which means they favor products, and you might get a pH in the 3 to 4 range, which is a very typical weak acid pH. And if they have a very, very small Ka, you might get a pH 12 to 13, which is actually going to be done as a Kb in the next lesson. So this would be a typical weak base, but we will have a separate lesson on Kb. When you go to write your Ka expression, Ka is products over reactants, so H3O plus times A minus is a refresher on the expression, all over HA, and there's only the one term on the bottom because water is a pure liquid and we don't count it in our Ka. In terms of what you can be asked to find, there's 3 things that a problem can ask you to solve for. So if you're given 2, you can find the third. So you can be solving for HA, which is the concentration of your acid to start with, Ka, or H3O and pH. Remember, they're linked with the same equation. Our first example gives us the Ka for acetic acid, CH3COOH, and it's asking us what is the pH. So we're going to go back to ice tables we remember from most of our year, and the starting is, this is my initial concentration, so I'm going to put it in there, and then star this piece right here. These first 2 lines on your ice table need to be 0, exactly the same as pattern as we followed when we did the KSP in Unit 3. Okay, there's 0 at the start because it doesn't ionize till you mix with water, so make sure you have zeros there. After that, I have no other numbers in my question I can use. I can't use the Ka until later, so I'm going to call this x, and this one x, so plus x minus x, and if I do some math, this will be 0.500 minus x. So now we come to the note I left for you. If you do it this way, it's going to require a quadratic. Okay, so to simplify, and we did this with the KSP as well, we assume the acid is sufficiently weak. So it's so weak, the amount of x that ionizes is tiny, meaning that it will not change the number. So we say this is assume approximately equal to 0.500 molar. Okay, so this is called state your assumption. So if you ever see that, your assumption is that x was so small that you did not have to include it in your calculation, because when you rounded for sig figs, it would all wouldn't show up anyway. Okay, now I'm going to write my Ka expression for this specific problem, which will be CH3COO minus times H3O, so that's my product side of my equation, over CH3COOH. Okay, and this works out to x times x over 0.500, so no quadratic, and it's going to equal the value of Ka given in the question, which was 1.8 times 10 to the minus 5. Okay, when you're doing your math, don't forget to take the square root when you're solving for x. So you're going to do 1.8 times 10 to the minus 5 times 0.5. Get that number on your calculator, take the square root. In the end, x should be equal to 3.0 times 10 to the minus 3 molar, and that will be our concentration of H3O plus. Okay, now this question wanted pH, so then we have to do our next step, which would be pH equals negative log H3O. Okay, put that in there in your calculator. So negative log 3.0 times 10 to the minus 3. Take a moment to do that. If you've solved that correctly, you should come out to a pH of 2.52. And a quick talk on sig figs, because they are different with pH. These two after the decimal are your 2 significant figures. So we're not counting the figure before the decimal in pH. Okay, the next section gives you a little note on percent dissociation to check if your assumption was correct. Okay, in order to do that, you do not need to do that for Chem 12. I just wanted to leave that there with you in case you encounter it in university. You do X over your initial times 100%, and in this case it worked out to 0.608%, means our assumption's okay. Usually it's acceptable between 5 and 10%. Sometimes your question will tell you it has to be under 5% if you are doing a university type problem, but we're assuming that between 5 and 10% is an okay dissociation to assume X is insignificant. Okay, our next problem gave us pH for 0.1 molar solution of HA. What is its Ka? So we don't know the gases' names. We can't just go look it up. So if we go on to our ice table, we're going to start by putting 0.1 molar in there. And of course, our 2 zeros have to go in the top line. Our next step will be to use the pH to find the concentration of H3O. So I put that over here for you. I got you started. pH is 1.7. To find H3O, remember you're going to anti-log this because your pH number is on the opposite side of the equal. So shift log or anti-log. And if you've calculated that correctly with a little rounding, we're going to do 0.0200. So that number goes here for H3O, so 0.02. I'm just going to take my sig figs off the end, and 0.02 because those two are correct. So this is plus 0.02 and plus 0.02. When I come to the other side of my equation, minus 0.02. Okay, so now I've got a note here under the E. Don't assume here you actually have numbers, so you can do the little math, 0.1 minus 0.02, and get 0.08 to do your calculating with. So you can't make an assumption if you have a number. If you have a number, put it in your calculator and do the math. Okay, so now we get to our Ka expression, which I wrote for you. A minus will be 0.02. H3O would be 0.02. HA is 0.08. And I can work all that out too and find out that the Ka is 5.0 times 10 to the minus 3. And just a reminder that Ka's have no units. Okay, so that one is solving for Ka. And our last example asks you for mass. So whenever you see mass, you should be doing that last, like the mole map from grade 11. So don't go there yet. And the 1.5 liter you're also going to have to use at the end. So we'll just put at end. And we will go ahead and draw our ice table since it wasn't already drawn for us. So ICE, here we go. Nope, don't do that. Sorry, guys. We need to write our equation first. I don't know if I erased mine and you guys have it, but it's NH4Cl plus H2O. Chlorine is a spectator, so really what I have is NH4 plus. So this will make NH3 plus H3O plus. Okay, so a little bit of our hydrolysis unit coming into play there, noticing that Cl minus is a spectator. Okay, here's my ice table here. And what mass of NH4Cl? Okay, so I really don't know this number, so I'm going to call that X. I'm going to solve for that at the end. These still have to be 0. Okay, so my next thing I do know is that my pH is 4.75, so I know this. So pH equals 4.75. So 4.75 equals negative log H3O. So into your calculator, you can anti-log that, which will look like 10 to the negative 4.75 will be H3O plus. And 1.78 times 10 to the minus 5 is your H3O if you have done your calculator correctly, and that goes right there. Okay, and also here, because those two are the same number, 1.78 times 10 to the minus 5. Okay, so then this is plus 1.78 times 10 to the minus 5 plus 1.78 times 10 to the minus 5, so same pattern, minus 1.78 times 10 to the minus 5. And this is a really tiny number, so this will be x minus 1.78 times 10 to the minus 5, which we can assume is approximately equal to x, because this number here would be 0.0000178. So that's a really small number. So we're going to assume that that is equal to x. Okay, and as our last step, we're going to put our Ka equals H3O plus times NH3 over NH4. Okay, if I fill in what I know, H3O and NH3 are 1.78 times 10 to the minus 5, and I'm going to just put that as a squared. Over x, I don't know that, which means I need to find Ka, so you're going to get Ka from your table. So go to your acid-base table and find this number from table. So once you have, and you're looking for NH4 plus on the acid side. Okay, so look down your table and get that number. Okay, now with a little bit of math, you can solve for x. In this case, x is equal to 0.565 molar. So that is the majority of our question done. However, this question, remember, wanted to know mass, so I need a little bit more space here, so I'm just going to move this up here. So I have 0.565 moles per liter. That's my molar. And this question told me I had 1.5 liters, so I need to do that. And then I need to do my grams on the top and my moles on the bottom to make them cancel. And the grams would be 53.5, and that is from NH4Cl. So you need to look up that guy, NH4Cl, add it up on your periodic table. So once that is all finished, your final answer should be 45 grams. I'm just going to put a little box around this, just separate it out from my other equation. This is my last step. It's a little bit squashed in there. Okay, so in my last step, I used my molarity and found 1.5 liters and the mass per mole, grams per mole, and discovered that I should have 45 grams. Okay, I also left you with a little explanation that can help you with what is Ka, so you can feel free to have a read through that. And that should take you to everything you need for your worksheet 4.14.